So this is Dr. Shankaraiah from Department of Physics, Associate Professor. So in the last presentation, I have discussed about topics in lasers and fiber optics, which is a module 3 in applied physics. So I've discussed about types of lasers and I've discussed about ruby laser. In this presentation, I am going to discuss about helium neon laser. Okay. So to to before understanding these lasers, we need to know about the different process that occur when light interacts with matter, and we also need to know the steps that are involved in lasing action, right? So yeah, so if we are once we are familiar with all those things, we can understand the laser easily. Okay, so in the last presentation, I have discussed about ruby laser. Ruby laser is a solid state laser, and the output mode in ruby laser is a pulsed mode output in ruby laser. And in ruby laser, we have taken chromium atoms as active centers, and the pumping agent is the xenon flash lamp. Okay. So now we are going to discuss about the gas laser, which is here helium neon laser. Okay. So gas lasers are most widely used lasers. They range from the low power helium neon laser used in college laboratories to very high power carbon dioxide laser used in industrial applications. So gas lasers are widely used as known, and they are used in labs and also in college laboratories to understand for the students to do carry out experiments in laboratories, and also used in industry. So they are ranging from small college laboratories to the very large labs in industry for different applications. Okay. So these lasers operate with rarefied gases as the active medium and are excited by the electrical discharge. Very. So in ruby lasers, we have discussed that we have used xenon flash lamp as the active agent, pumping agent. But in this helium neon laser, we are going to use electrical discharge as the pumping agent, and we will discuss the reason, right? So why we are not able to use xenon flash lamp, for example, as a pumping agent. Here we are saying that we are going to use electric discharge as a pumping agent. Okay, the reason is that in gases, energy levels of atoms involved in lasing process are narrow, and as such require sources with sharp wavelength to excite atoms. So in gases, the energy levels are very narrow. Though in the lasing action, the energy levels that we are needed in gases, if you take gases, the energy levels are in very narrow energy band, and the if you want to use pumping agent, the pumping agent should be having sharp wavelength to excite atoms from the ground state to the excited state. Okay, finding appropriate optical pumping agent is not used in gas laser. Okay, finding an appropriate optical source pumping poses a problem, because we need pumping optical source which is having very sharp wavelength, as the energy levels are very narrow. That is the reason why finding the optical source with a very sharp wavelength is very difficult. That is the reason why we are not going to use optical pumping as a pumping agent in gas laser. Instead, the most common method of exciting gas laser medium is by passing electric discharge to the gas. Okay. So electrons present in the electric discharge transfer energy to the atoms in the laser gas by collisions. Okay. So the main reason for this pumping agent is that we want to excite the atoms from the ground state to the excited state. So and in gas lasers, the energy levels are very narrow, and if you we cannot use the optical source, because it is very difficult to find the optical source with a sharp wavelength that can excite the atoms from energy levels which are very narrow. That is the reason why we are replacing this optical source by a electric discharge. How we are able to how do we can excite the atoms using electric discharge? Using electric discharge, the electrons which are present in electric discharge, these electrons are going to transfer energy to the gas atoms in the ground state through collision. When the electrons collide with the gas atoms, the electrons are going to transfer the energy to the gas atoms. Once the atoms absorb the energy, got the energy from the electrons, they are going to excite to the and excited states that are available in the system. Okay. Coming to the construction, okay, helium neon laser construction. So the first gas laser was helium neon laser, which was invented in 1961 by Javan William Bennett and Donald R. Harriet Jr. Okay, so these are the scientists who invented the first helium neon gas laser. Okay, so this is the construction of helium neon gas laser. Coming to the construction of the helium neon laser, so these are the three scientists who worked very hard to invent this gas laser for the first time in 1961. So this is the construction of helium neon laser. So look at this narrow glass tube. We are going to use a narrow glass tube, and this narrow glass tube is filled with helium neon gas. So here you are going to have helium neon gas, and these ends of this narrow glass tube are connected to mirrors, and okay, they are fixed, they are tightened so that there is no leakage of the gas, and there are mirrors on both sides of these glass tube, so that these mirrors are going to reflect the atoms. Okay, so basically we are going to we need a optical resonator. So that is a here we have constructed a optical resonator. So this narrow glass tube is the active medium. So narrow glass tube is the active medium. So here you have a active medium. So active medium is nothing but host material plus active center. So we will discuss what are the active centers in helium neon gas, but you need active medium plus there are two mirrors for the optical resonator. So these two mirrors are provided at the two ends. Okay, and then these narrow glass tube is connected to electrodes. So you have anode and cathode, and we will discuss why do we need to connect this to anode and cathode. Okay, well, let us discuss in detail the construction of this helium neon gas. Okay. Yeah. So coming to the construction, the schematic of helium neon gas laser is shown here. Helium neon laser consists of a long discharge tube filled with a mixture of helium and neon gases in the ratio of 10:1. Okay. So this narrow glass tube, so this is what I'm talking about. This narrow glass tube is filled with helium and neon gases. We are taking long discharge, narrow, and it's very important that this glass tube is very narrow, and there is a reason that we are taking very narrow, and this narrow glass tube is filled with helium neon gases in the ratio of 10:1. That means for 10 atoms of helium there is only one neon atom. Okay, so neon atoms are less compared to the helium atoms. So 10:1 ratio of helium and neon gases are filled in this long narrow glass tube. Neon atoms are active centers. Okay, so here neon atoms are the active centers and have energy levels suitable for laser transitions, while helium atoms help in exciting neon atoms. So we got these active centers. So in the active medium, the active host material is helium gas, and the active centers are the neon atoms. And the neon atoms are in the ratio very less compared to the helium atoms. If there are 10 helium atoms, there is one neon atoms for those 10 helium atoms. Okay, electrodes are provided in the discharge tube to produce discharge in the gas. Okay, so we have connected this narrow gas tube to the electrode so that we can produce the electric discharge in the gas. Okay, that is the reason why we have connected this glass tube to these electrodes. Okay, they are connected to a high power voltage supply. They are connected, these electrodes are connected to a high power voltage supply so that we can provide this electric discharge. The tube is hermetically sealed by inclined windows arranged at its two ends. So this tube is hermetically sealed, means tightly sealed. Okay, by inclined windows arranged at its two ends. So these here, so there are two glass windows. So we using these two glass windows, these narrow glass tube is tightly sealed so that there is no leakage of the helium neon gases. Okay, right. So long narrow glass tube filled with helium neon gases in the ratio of 10:1, and the ends of this narrow glass tube are tightly sealed with na- glass windows so that there is no leakage of gases. Fine. On the axis of the two mirrors are arranged externally, which form the Fabry-Perot optical resonator. Now, at the ends of these glass tube, there are two mirrors. We are setting up two mirrors. These two mirrors will act as front one is partially reflecting and the back one is 100% reflecting. There are two mirrors, and with this setup, two mirrors at the front and back, and in the center there is a active medium in the narrow glass tube. So active medium contains host and active centers. So now this setup forms a Fabry-Perot optical resonator. So basically we have a optical resonator, but in this helium neon gas lasers, so this is called as Fabry-Perot optical resonator. Okay. So this is the construction of helium neon gas laser. Okay. So to revise, you have a narrow glass tube. This narrow glass tube is filled with helium neon gases. Okay, in the ratio of 10 is to 1. That means for 10 atoms of helium, there is only one atom of neon. Okay, once we fill these helium neon gases in the long narrow glass tube, we are connected this glass tube to electrodes so that we can produce the electric discharge in the gas. We need to produce the electric discharge in the gas because we are using the electric discharge as a pumping agent. Fine. To avoid the leakage of these helium neon gases, the two ends of this narrow glass tube are tightly sealed by glass windows, right? And then we are providing two mirrors at the two ends of this narrow glass tube, and for the reflection of the emitted photons. Okay. So this is the construction of helium neon gas laser. Fine. Okay. So coming to the working, right? So this is the construction, and coming to the working of this helium neon gas laser. So these are the energy level structure of helium atoms. So this is the energy level structure of helium atom, and this is the energy level structure of neon atom. Okay. So this is helium and this is neon atom. So helium neon. Helium atom has ground state F1 and excited state or metastable state F2. Helium atom has two energy levels, ground state F1 and excited state F2. And this excited state is a metastable state. Okay. Coming to the neon atom has ground state as E1, and there is a metastable state. Okay. There are two metastable states in this case. I think E5 is a metastable state and E3 is also a metastable state, and E2 and E4 are normal excited state. So neon atom has two metastable states, and there are two normal excited state and there is one ground state. Okay, so these are the energy level structure of helium and neon. Fine. Okay, so we need to see there should be five steps for the lasing action. So the first one is pumping mechanism. Okay, so how does the pumping mechanism occur in this helium neon laser? Okay, when the power is switched on, when a high voltage of around 10 kilovolts is applied to the gas mixture and it ionizes the gas. Okay, so we have connected this long discharge tube to the electrodes, and that is connected to a voltage supply. And then when we switch on the power, there is a 10 kilovolts voltage, and which produces electric discharge in the gas. When the electric discharge is produced in the gas, there is a transfer of there is a losing of electrons and gaining of electrons. So there is a ionization of the gas. Okay, so the electrons and ions produced in the process of discharge are accelerated towards the anode and cathode respectively. Once the electric discharge is produced in the gas, there is a generation of ions, because losing and gaining of electrons will give us the ions, and these positive ions will move towards the cathode and negative electrons will move towards the anode. Okay, so they collide with the helium and neon atoms on the way. Okay, so once these electrons are produced in the gas mixture, because of this electric discharge, the electrons are going to collide with helium neon atoms that are present in the electric discharge. The energetic electrons excite helium atoms more rapidly as they are lighter. Okay, as the electric discharge produced in the gas, these electrons present in the electric discharge, these electrons are going to collide. Electrons are going to collide with the gases present here, and they are going to transfer energy to these helium neon atoms with the collisions. But out of these helium and neon atoms, helium atoms are the lighter ones, so they are going to get excited first. Okay, so these are the energy level structures of helium neon atoms. Okay, one of the excited levels of the helium atom F2. Okay, let me see. Yes, one of the excited levels of the helium atom F2 is around 20.61 electron volts above the ground level. So helium atom has two energy levels. F1 is the ground state and F2 is the metastable state, which is having energy around 20.61 electron volts. Okay, so it is a metastable state. So F2 is a metastable state of helium atom, and the excited helium atom cannot return to the ground level through spontaneous emission. So because it is a metastable state, the lifetime is long. It is not going to decay to the ground state in 1 nanosecond. So how does it come to the ground state? However, the excited helium atom can return to the ground level by transferring its excess energy to a neon atom through collision. Okay, so now the helium atom, which is present in the metastable state F2, is going to transfer its energy to the neon atom that is present in the ground state, and then by after transferring energy to the ground state, the helium atom is going to decay to the ground state through spontaneous emission. Okay, such an energy transfer can take place when the two colliding atoms have identical energy levels. Such an energy transfer is known as resonant energy transfer. Okay, the transferring of energy from one atom to another atom is always not possible. It is possible only when two atoms are having identical energy levels. For example, here helium atom has energy level which is having energy 20.61 electron volts, and neon atom is having energy level which is having 20.66 electron volts. These two atoms are having energy levels which are almost same. That is the reason why now helium atom can transfer energy to the neon atom, because these two atoms have identical energy levels. Such transfer is called as resonant energy transfer. Okay. So because through this resonant energy transfer, the neon atoms are going to decay to the ground state through spontaneous emission of transferring energy to the neon atoms present in the ground state. Okay, the neon energy level E5 is at 20.66 electron volts, which is close to the excited energy level F2 of helium atom. Therefore, resonant energy occurs between the excited helium atom and the ground level neon atom. The kinetic energy of helium atoms provides the additional 0.05 electron volts required for excitation of the neon atom. Okay, so the kinetic energy that is given, kinetic energy of helium atoms, okay, that is given as additional energy that is required for the neon atoms for the excitation from the ground state to the excited. Helium atoms drop to the ground state after exciting neon atoms. This is a pumping mechanism in helium neon laser. Very good. Okay, once the helium atoms are excited to the excited energy level F2, how they are excited? Because of the electric discharge, electron transfer energy to the helium atom because they are lighter. By absorbing the energy from electrons, these helium atoms are going to get excited to the metastable state F2. Now, F2 is a metastable state, so helium atoms are not going to decay to the ground state through spontaneous emission easily. They are going to wait up for some time. Okay, instead what they are going to do, they are going to transfer their excess energy to the neon atoms present in the ground state. So they are going to transfer neon atoms energy to the neon atoms, and then they are going to decay to the ground state through spontaneous emission. Such energy transfer is called resonant energy transfer, that can occur only when two atoms are having identical energy levels. Now, because the neon atoms are gained energy from the helium atoms, they are going to excite to the energy level E5. Okay, E5 is around 20.66 electron volts. Remember, neon atoms are having only, helium atoms are having energy around 20.61 electron volts, but neon atoms are having energy level is around 20.66 electron volts. So the additional energy around 0.05 is given by the kinetic energy of these helium atoms. 20.61 plus excess 0.05 is given by the kinetic energy of helium atoms. So through the kinetic energy, helium atoms provide additional energy to this neon atoms, so that neon atoms can excite from ground state to the energy level E5, which is having 20.66 electron volts. Okay. So the pumping agent is the electric discharge. Okay, now pumping mechanism. First step is completed. The second step is population inversion. So the upper state of neon atom E5 is a metastable state. Therefore, neon atoms accumulate in this upper state. The energy level E3 is positive populated at ordinary temperatures. As the population at the higher energy level E5 is greater than the population at the lower energy level E3, a state of population inversion is established between E5 and E3 energy levels. Okay. Yeah, sorry, I think in the beginning I mentioned something wrong. So the energy levels of neon, E5 is a metastable state, right? E5 is a metastable state, and then E2 is also a metastable state. Okay. So E3 and E5 is a metastable state, both are metastable state. Once the neon atoms excite from the ground state to the metastable state E5, okay, metastable state E5, sparsely populated at ordinary temperature. So what we are saying is that E5 is a metastable state, but as the neon atoms excite from ground state to different energy levels, the number of atoms in E5 are more compared to the number of atoms in E3. Okay, so then there is a population inversion achieved between E5 and E3. As the population at the higher energy level E5 is greater than the population at the lower energy level E3, a state of population inversion is achieved between E5 and E3 energy level. Okay, so here the population inversion is achieved between E5 and E3. So E5 is the upper lasing level and E3 is the lower lasing level. Out of this, E5 is a metastable state. Very good. Now, once the population inversion is achieved, there should be spontaneous emission that occurs in lasing action. So, random photons of red color of wavelength 6328 angstroms are emitted spontaneously by a few atoms at the energy level E5. The spontaneous photons traveling through the gas mixture prompt stimulated emission of photons of red color wavelength around 6328 angstrom. The photons bounce back and forth between the end emitters, causing more and more stimulated emission during each passage. The strength of stimulated photons traveling along the axis of the optical cavity builds up rapidly, while the photons traveling at angles to the axis are lost. Okay. So once there is a spontaneous emission from excited state E5 to energy level E3, there is a photon that is emitted because there is a spontaneous emission of atom from E5 to E3. Okay, so this photon is going to come back because there are two mirrors at the end. This photon is used for the stimulated emission to occur. So this is the initial photon. So because of the spontaneous emission, so there is a spontaneous emission that occurred as the neon atom undergoes a spontaneous emission from E5 to E3. So E5 to E3 neon atom undergone a spontaneous emission emitting a photon. Because of the mirrors present, this photon is going to come back as input photon. This photon is used as a trigger for the atoms to undergo stimulated emission. Okay. Now, after the spontaneous emission, there is going to be a stimulated emission, and as the photons, more and more coherent photons are emitted that are going to bounce back because of the mirror, these are going to trigger more and more neon atoms to undergo stimulated emission. Okay. So the transition from E5 to E3 generates a laser beam around 6,325 angstroms. So as the more and more neon atoms undergo stimulated emission from E5 to E3, there are more coherent photons generated, and these coherent photons are going to undergo constructive interference, and hence there is going to be amplification of light, and the light that is emitted in the helium neon laser is around having a wavelength around 6,328 angstroms. So from the level E3, the neon atoms drop to E2 level spontaneously. E2 is a metastable state. Very good. So E5 and E2 are metastable state. Once you have population inversion between and E5 and E3, you have a laser beam that is coming out, having wavelength 6,328 angstroms. But atoms which are in E3 will decay to E2 spontaneously, but E2 is a metastable state. Consequently, neon atoms tend to accumulate in E2 level. So what happens to the atoms in the neon atoms to the E2 level? Neon atoms return to the ground state E1 through frequent collisions with the walls of the glass tube holding the helium gas neon mixture. That is the reason why in the beginning I mentioned that the narrow glass tube we are going to consider is going to be very narrow. We have taken intentionally the glass tube as narrow so that the atoms which are present in E2, which are accumulated in E2, will go to the decay to the ground state through collisions, frequent collisions with the walls of the glass tube. That is the reason why we have taken this glass tube as very narrow. The neon atoms once again available for the excitation of higher state and participate in lasing action. The neon atoms are excited to the upper lasing level continuously through collisions. As the population inversion can be maintained in the face of continuous laser emission, the laser operates in continuous mode. Okay, so in helium neon laser, we are going to get continuous laser beam because there is a population inversion that is sustained continuously in this helium neon laser. Okay, what is the role of helium atom? The role of helium atoms in the laser is to excite neon atoms and to cause population inversion continuously. Okay, so the probability of energy transfer from helium atoms to the neon atom is more, as there are 10 helium atoms per 1 neon atom in the gas mixture. The probability of reverse transfer of energy from neon to helium is negligible. That is the reason why we have taken 1 neon atom to the 10 helium atoms. So the reverse transfer is negligible. Only helium atoms can transfer energy to the neon atoms. And yeah, the salient features of helium neon laser. In this laser, we have a 4-level pumping scheme. Okay, there are 2 metastable states and one normal excited state and one ground level. Okay, 4-level pumping scheme, and the active centers are neon atoms. Electrical discharge is the pumping agent. Low efficiency and low output power operates in continuous mode. Okay, so I'm going to end here. In the next class, we will discuss some numerical problems that are before numerical problems. We will discuss. Yeah, so we will see what we can discuss in the next.
Like, share, and subscribe. Hit the bell icon for more updates.